Hello, if you've seen any of my other videos recently, you might have noticed that I've been talking occasionally about making a GPS car tracker using an Arduino and a GPS module and a GSM or SIM module. And that's what this is. So this big old mess of stuff here is actually functioning as a GPS tracker. So there's two parts to it. You just have to read in the current location using the GPS, and then you use the SIM module, or the SIM module, to send that to a web server. So I guess there's three parts to it, really, isn't there? There's a web server as well, and then you can look at it afterwards and see the recorded journey that you took. So it's running here at the moment. So there's quite a lot to look at, really, but let's start off just by looking at this little screen here. I found that I really had to add a screen on because there's quite a lot going on, and if you don't have some immediate feedback as to what it's doing, it's just a nightmare to figure out what's going on. And the way I'm working, the way I'm getting this input is I'm using software serial to talk to the GSM module or the SIM module. When I say GSM module, I mean the SIM module, so I'm sort of use those names interchangeably. So that's running on software serial. And then I also want to talk to the GPS, but I found that you can't really do two software serials, at least not very quickly and not very successfully. So I ended up using pins 0 and 1, which is just the normal hardware serial of the Arduino, to talk to the GPS. But that means that you can't use the serial monitor to display any debugging info. So that's why this screen became all the more important. I also tried this on an Arduino Mega 2560, which has two hardware serial ports, and that made things a lot easier. So if anybody wants to try this, you might find it a lot easier to do it with the Arduino Mega instead of the ordinary Arduino Uno. But anyway, back to the story. So in the very top left, there is a little spinner character that just turns around and around, and that's just to let us see that the program hasn't crashed and it hasn't just, frozen. So we want to make sure that something's happening. SV5 means that there are 5 satellites currently locked. The 200 to the right of that in brackets is the HTTP request status that was returned last time we did a request to the server, and we want to see that as 200 because that means it's a successful request. And the reason it goes to 0 every now and then, like that means that there's a HTTP request currently in progress. So it sets it to 0 to let us see that it's doing a request, and you'll also notice that the other stuff pauses for a bit while it's doing that. Oh, not really. So this was another very important thing. You want to see whether your requests are getting through to the server successfully or not. And if they're not, you want to see what the HTTP request error status was. So sometimes it comes back saying 504, which means stack busy, which means that you've tried to start another request while there was already a request in progress. And I've also seen a 604 and a 601, which are something to do with, I think was one is where you're not signed on to the internet network properly in your mobile cellular provider, and the other one was just sort of a more general error that I never really figured out, but I haven't seen it much. Okay, so just below that we have the latitude and longitude, and those are the numbers directly read from the GPS, and you divide those by 1,000,000, I think, to get numbers in degrees. And just below that we have HACC, which is horizontal accuracy. That is a measurement in millimeters. Yeah, so it's like 14 meters at the moment, 15 meters. So it's not very accurate. We're indoors and we only have 3 satellites. The next one is ground speed. That's a number in millimeters as well, so that's about ½ meter per second, which was obviously incorrect. And just below that we have, it looks like aid, but it's actually head, and that's the heading, and that's in degrees multiplied by 10,000, 100,000, sorry. So at the moment it's reading 312 degrees. And that's also wrong because we're not really moving. So this screen, this is the Nokia 5110 screen. And this turned out to be a very good screen because it runs on SPI and has quite a fast update rate. And it doesn't seem to use a whole lot of memory. I also tried with one of those little tiny 128 by 64 pixel OLED screens, but the amount of memory that it uses, I think, just smashed all the program that was trying to run other stuff. So it just was untenable. You couldn't have that screen working with the amount of memory that this program is using. Right, so on the other side of this we have a web server, and this is the we just got one there, did we? Let's see if we can catch this in the act. I have to put that on top. So there we go. Alright, so that went to 0 there. Maybe you just caught it. Hopefully you just saw that. But you can see that we've just sent the information here. So 5 satellites, fixes 3 meaning a proper 3D fix, and then we have the lat long and those other variables that I just mentioned. And over to the right here there's one other variable that it's sending, and that is a 10-character journey code. I'm calling it a journey code, and we'll see what that is all about when we look at the source code in a minute. But to look at the final output that we get from this, because that's probably what you're interested in right off the bat. So this is a Google map displayed in the web browser, and we can mouse over these points and see all of that information. And the ground speed I've converted to kilometers per hour here, of course, because that's a bit more sensible than looking at it in millimeters per second, or yeah, millimeters per second. So you can see I was driving at 47 kilometers an hour, horizontal accuracy of 1.3 meters on the 23rd of February at 7 minutes past 5 in the evening with 8 satellites. So each one of these points has all of that data recorded for it. And because it's doing it every 10 seconds, it's you don't see nice smooth lines. So obviously I didn't drive through these people's backyard. I drove around the corner, but occasionally it looks like it's cutting off or going strange. But each one of these individual points, in the heading you can see there from the arrow, each one of these points should be accurate. So it's only the lines in between them that are not accurate. Alright, hopefully that makes sense. So you can see I drove around there, back over there, around there, and sometimes from the frequency of these arrows you can get an idea of how fast I was going. So I was doing 40 there, and then we got more arrows here, so obviously it's a bit slower, and yeah, 18 kilometers an hour there. And over here it looks like I stopped at this shop. It's a supermarket, I think, and you can sort of roughly see where I parked. I think I parked in this one. But over a while, let's see, how long was I in the supermarket for? 17:15 to 17:44, about half an hour or so I was in the supermarket. The blue circle is the accuracy, horizontal accuracy, so it's 1.3 meters there. Some of these other ones look a little bit bigger, 1.8 meters. It's interesting that when you're moving faster, that accuracy seems to get better. I would have thought it would be the other way around, but no, it actually gets better when you're moving faster. So let's have a look at some photos that I took, or some screenshots of some other journeys. So what I'm calling as a journey is each time I come home I'll change that 10-character code so that I can differentiate each trip that I've been out somewhere. So this is another trip, and you can see You can see I just drove around town a bit, and I guess it'll be more interesting for you to look at your own ones if you make some. But this is another town one. What did we do? This is the one that we just looked at, I think. Okay, this is a little bit more out in the country. And you can see that we get pretty steady measurements, so the arrows here are fairly equal distances apart, and most of this was open road, so I was doing about probably 100 kilometers an hour along there. This road here, you can see it's a little bit slower, arrows are a bit closer together, but there's nothing missed out much. Now this part here, I was a little bit disappointed to see some big gaps in the recordings. So I'm talking about these big long straight lines. You can see it's jumped. That is not 10 seconds. I didn't get from there to there in 10 seconds. Neither did I get from there to there in 10 seconds. But it's interesting that they're in the same place roughly. So I recorded, I've been at this for a bit, like probably a month almost now, and I recorded a few more. So take a look at that, and then take a look at that. There's more gaps, and there's a huge gap, and there's even this problem was even worse down there as well. And then there's more gaps, and they're all in the same place, and either side of that gap we're getting generally fairly good readings. There's a little bit more. That was probably the best day, but we still got some longish gaps in that middle section. And then we have something terrible on that occasion. And what I'm guessing here is, so this is the area there. So you can see right about there we get some missing gaps, and then this other area that I just mentioned down there is even worse. So what I'm theorizing this is it's just simply a lack of the cellular coverage, because this is quite a rural area, as you can see from those other maps. So I'm just guessing that there's just not enough cell phone coverage there to report the location. What else do we have? Oh, okay. On this occasion, I pulled into the gas station and I parked under this roof. So I was actually under the roof here. See that car there? I was probably about there, or there maybe. And you can see that the you get less satellites. Actually, is it less satellites? Oh, this is a screenshot, so I can't see what the satellites were. But you can generally see that when you're getting wider circles, the accuracy is lower. And this is another situation here. It seems to drift quite a bit when you're parked, but you can see here, this is supposed to be all in one spot, and so is that. What else we got? And this is probably the worst of the parked cases where the accuracy dropped quite a lot. So you can see here, not only has the accuracy dropped, so this is where I'm supposed to be, the accuracy has dropped, but it's also moved way over there as well. So none of these large blue circle readings are very accurate, and I'm not really sure why, because I wasn't really parked under a roof or anything. So I guess just occasionally it's likes to be inaccurate. Right, what else do we have? Okay, so this is what I was saying about very accurate in the faster section. So this is a section of road that's nice and long and straight, and I was doing 100 kilometers an hour along here both ways. And in this situation, the accuracy was always very good. And I mean, it's so good that these two lines look almost like perfectly parallel lines, because it's clearly placing me on one side of the road there and the other side of the road there. The lines don't exactly match up perfectly with the map underneath it, but they do match up perfectly with the other line, which is really nice to see. So yeah, faster speeds generally gave better better horizontal accuracy results. Have any more photos? Okay, I think that's all the photos I had to look at. So now we need to look at the source code, right? So, like I say, this is something I've been working towards for a while now, and in my other videos in the last couple of months I've described or explained a lot of the code that's gone into this. So we have some tabs here, so I'll just explain these other tabs first. In fact, there's not really much to explain. The offset tab is just putting a little offset to so that I don't show my exact location on YouTube, because I don't really want any of those hot swimsuit models stalking me anymore. So the GSM is, let's start with GPS. Oh, what was this? Let's just save that. Right, so the GPS stuff, I've done quite a few videos on this now, so I won't describe it in too much detail, but I'll just point out a couple of little changes that I've made from previous videos that I've done. The first is that I'm using the nav PVT message, whereas previously I was using nav pos LLH or something like that. And I'm using this one because it has the fixed type, and it also has the ground speed and heading somewhere or other. So it has quite a lot of useful information, and it also gives us a nice year, month, day, hour, minute, second time. So that's the message that I'm using. And as well as that, I'm also keeping a separate structure to copy some parts of that nav PVT structure into. So these are just the things that I'm interested in keeping and giving to the server. And we need to keep a separate copy of that, because when we read in bytes from the GPS, we're continuously overriding those bytes or writing those bytes into this structure. So there's only one point in the program, and that's here. This is the only point in the program where we can be guaranteed that we have a fully intact GPS message or packet or structure, the nav PVT thing. So at this point here we need to just copy all of those member variables that we want to look at into a second structure, so that we can use that structure knowing that it's not going to get overwritten the next time we read a byte from the GPS. So I think that's all I did there. That was different. Yes. Alright, so for GSM, or the SIM module, this is all pretty much the same as I've had it in my previous videos, with the exception of HTTP result. This variable here, I added that, and I'm keeping this as a global variable, and then when we read the response back from the server, we set it here like this, HTTP result equals, and then we just look at the number that it gave back to us at that point. So this is where I'm getting the number 200 from that we saw on the screen before. And I haven't really bothered to look at this before, but for this sketch it is very important, so I'm doing that there. I think everything else is unchanged. One thing in here I just noticed when I was looking at this before making the video, when we get the response back from the server, and before we were in one of my previous videos we were looking at this to check some content that we got back from the web server. As the sketch stands, or as this little GPS tracker thing stands at the moment, we don't need to look at the content that the server gave back to us. We're just ignoring it. So this thing here where we read what the server told us is actually unnecessary. But I'm just leaving it in there because everything was working and I didn't want to mess it up. And it could be useful in the future. So that's all there is to look at for that. Now this page here, GSM GPS tracker, is obviously new. Why is it not saved? Okay, so this is where we're going to have a little bit more in-depth explanation. So at the beginning of this file we define a 10-character string to use as the journey ID. So this is just a string that you can choose randomly, just choose 10 characters, it doesn't matter what they are. And I've put if anybody wants to use this, you can use my server and all that stuff. Where is it? This one? Yeah. So like I say, it doesn't really matter, but if you want to make sure that you're not going to use anybody else's journey ID, you can use this URL here and just change the last bit at the end to the journey ID that you want to use, and it will tell you whether that is available at the moment or not. So yeah, check that if you want to be polite, I guess. Oops. Alright, so that's the journey ID. This stuff here I've included for the screen, and at the top here I've defined use screen. So if you comment out this line at the top, none of the screen stuff will come into play. So you might just not want to have a screen, not recommended probably, or you might want to use your own screen. In that case, wherever we have this use screen stuff, you're going to have to put in your own code to use a different screen type. And then I just have some setup for the Nokia 5110 screen. And at this point here, there's a couple of things you can do. You can choose these two things here if you want to run it on a Mega 2560, and that will let you use serial port 2 on those pins to do some debug output. Oh sorry, no, for the GPS. And debug serial will go on to the normal serial port. Now if you're using a Mega 328 like an Arduino Uno, you would have to have these ones, and actually it would be nicer if we commented one of them out, wouldn't it, just to be clear about what we're doing. It doesn't really matter, but that would be a nicer way to have it for readability. So in this case we only have one hardware serial, so we're using that for the GPS, and an undefined debug serial. Debug serial just prints out some stuff in, for example here we have this if-def debug serial. That would just print out something about what the GSM module is doing and stuff. But we can't do that if we're using the GPS on this serial connection. So that's why I have this undef, and everywhere I'm using serial, I have this if-def checking around it. Right, so you'll choose either that or that depending on which board type you're using. And up here, I guess this is not really necessary, but define GSM port GSM. Actually, I think we can ignore that because I've kind of forgotten that it was there, and I'm not really using it. But oh yeah, I guess this is what it's for. So you could also direct your software serial, whatever port you're using to talk to the GSM module, you could change that here. It's probably not very clear, but if anybody's following this so far, hopefully that will be clear to you what this is doing. So this is going to become GSM. So software serial is going to be, when the program's compiled, it's going to do that. So then we can see later on we are using, for example, GSM, using that GSM variable to print stuff out to the GSM module. Oops, now where was I? Alright, so now we have a big bunch of bytes here, and I also covered this in one of my videos quite recently, and the point of this is to give some instructions to the GPS module about what kind of messages we want to get from it. And here we're saying we don't want any of the text-based NMEA messages, and then we just, to be sensible, we disable those UBX ones, and then we enable just the one of them, and it saves. I know it seems a little bit unnecessary, but I've on two occasions now I've wasted over an hour because I forgot that I had one of these other messages turned on in my GPS module. So to be sure about it, I turn them all off, at least the ones that I've been playing around with, and then I turn just the ones that I want on. And then we also say This is probably not necessary considering that we're only we're only sending results to the server every 10 seconds, but just for fun I've made the GPS give us results every fifth of a second, which gives us some nice fast updating display on the screen here. Just nicer to look at, really, isn't it? Okay, so this bunch of bytes here, we're going to send that to the GPS at the start of the program. And speaking of start of the program, here it is. So we have 9600 baud on both the GPS and the SIM module, and if we're running on a Mega, we can also have a third port for serial monitor debugging on 9600 as well. And then we draw something on the screen just to say we're starting, and wait a bit, and then we send that stuff to the GPS module to tell it what kind of messages we want to see. Print something else to the screen. Wait 10 seconds for the GSM module to connect to the mobile network. This is quite important. I've never seen it take more than about 5 seconds, but I thought I'd give 10 seconds just to be safe. And then we need to set up the GSM module to say which access provider N, what is N, network? Access provider network maybe, that we want to use. And I looked at this in one of my previous videos as well. I'll try and put a link in the description to the previous videos that are relevant for this stuff. Then we print something to the screen again, and then at this point we call process GPS, just so that the first time we display something on the screen, we can, instead of displaying all zeros, which is what we'll have at this point, we can display the actual values that we got that are currently known by the GPS. Alright, and then we say done and clear the display, and then we go into the loop function. Now there's a helper function here called flush GSM, and all that does is read in whatever bytes the GSM module has currently given us and process them. And I found this to be very, very important, as we'll see a little bit further down the page. We really need to get everything out of that buffer as quick as we can so that we don't miss anything. So that's what this is going to do. Let me just have some characters for the spinner. So this 0 is just keeping track of which position we are in here, and we just cycle around to make that bar look like it's spinning in the upper left of the screen. And then in the loop function we check the GPS, and if we are in the action state idle, which means we are not currently sending a message to the server, then we check if we have a valid fixed type and if we haven't sent a message for 10 seconds. And if that's the case, then we come in here and we send a message to this URL, and so you can see all the parameters here. JN is short for journey, TM is short for time, and we just append all of those time member variables, the year, month and day and everything, into one parameter. So I guess it's pretty obvious what's going on here if you are familiar with URLs. There's a bunch of parameters that we're giving, and then we do one. See, this is here again, we're trying to get something from the GPS. And then another thing is that we also need to do that for the GSM, I meant to say there. We also need to process messages out of the GPS as quickly as we can too. So we can't leave neither the GPS or the GSM alone for any length of time. We have to quickly process whatever they give us. So that's why we'll have process GPS in here, process GPS again after that. So this, I think maybe this takes a little bit of time. I can't remember. Maybe that takes a little bit of time, and in that time we need to quickly catch up with what the GPS was doing. Right, and then we set the action state to waiting for a response. So if that if statement was not true, it means that we are currently waiting for a response from the server. So we've already sent a GPS location and we're just waiting to get the server's reply. And I found that sometimes if the server can't reply, or the internet connection is bad, or the cellular area is weak, like we saw in the maps, that response will never come. So in that case we have to give it a timeout. In this case I'm waiting 15 seconds, and if we don't get a response within 15 seconds we just reset everything back to the beginning state. So we say action state is idle, past state is that, and then reset the buffer. So these things are normally done in the GSM tab there, but we're just sort of doing them here as a once-off thing occasionally if it's necessary. Right, and so if you don't have a screen, that's about all you need to do. And we just flush the GSM and update some timing state. Now if you do have a screen, every half a second, so that's 500 milliseconds, I'm doing this stuff here. Clear display, flush GSM. Now look how many flush GSMs I had to put in here to get this to work. Flush GSM, flush GSM, flush GSM. So basically after every couple of writes to the display, to the screen, I'm catching up with whatever the GSM module was doing, just to make absolutely sure we don't miss anything. So all this is doing here is putting the display on the little Nokia screen that we saw right at the beginning of the video, and that's about it. There we go. So yeah, so if you want to use this, you can by all means help yourself to where's it gone? So that's the URL you'll need, GT standing for GPS tracker, and then these are the parameters that you'll need to give it. And to look at those parameters, you can use a URL like this. Hold on a second. I didn't prepare this. Hold on a second. Let's grab that. So say you wanted that, it was your journey ID that you wanted to look up. You would use this URL. I suppose I should put this in the link in the description as well. So this is the kind of URL that you'll need to access this page here with your tracker results on it. So it's iforce2d.net gt index php, and then again we have jn, which is short for journey, and then you'll put your journey ID there, the 10 characters, and then tz is a time zone, and this is your offset from UTC, or Greenwich Mean Time. And in New Zealand we are plus 13 from Greenwich Mean Time, so that's why I have a 13 there. So you could make it, you know, -9, or no, yeah, whatever you need to put for your time zone. That'll just change these. When you do this mouse over on each of these data points, it will change the displayed time there to your local time, just to be a little bit more useful. So that's time zone. Offset means, let's say you've recorded 500 points in your journey. Offset will let you start the display from, not from the beginning, but in this case from the 100th point. So I found I got a lot of garbage at the beginning before the GPS got a lock. So in that case I only wanted to start from about the 15th or the 20th point most of the time when I'm looking at my results. So that's what OS is, offset. And LT is limit. So it's a little bit like offset, but it's, for example, offset equals 100 and limit 150 means that we would start from point 100 and we would go up to point 250. So the last point would be, well, this is the number of points you want to look at. Think of it that way. So that just lets you define a range of points in your journey to look at. And I guess that's about all I wanted to cover for this video. So this little tray that I have it sitting on here, this is actually a rubber, it's like a thick wetsuit kind of material, and I just put it on here with some sticky double-sided tape on the bottom and stuck it on my dashboard. And the idea of this was to reduce the vibration that it got while it was sitting there, and also to stop it sliding off onto the floor. And I'm running it from a little 3S LiPo. Oh, and one other thing I didn't mention here is that there's a little voltage regulator on there. Well, not really that little compared to what I usually use, but this voltage regulator is capable of 5 amps, I think, because the GSM module apparently can pull 2 amps when it's in full-on transmit mode or whatever it does. But I figured that, well, I was told that you can't really run it from the Arduino. The reason why I ran it successfully through the Arduino before, I think, was because it was running on USB power and it wasn't actually using the voltage regulator that's on this Arduino. But the voltage regulator that's on there is not capable of pushing out 2 amps when it's converting it down from a 3S battery or whatever. So anyway, this was just to make sure that there was enough power for everything to run. So yeah, I just put it on my dashboard and drove around, and that's what I got. So I'm not sure what I'll do from here on. It would be nice to make it tidier, make the whole thing about that big would be nice. But I don't know if I can be bothered. It's just more really the challenge of making it for me. That's the attraction, and seeing what kind of results we can get. Anyway, so if anybody wants to give this a try and you get stuck, which I'm anticipating that this, of all the things I've uploaded to YouTube so far and given the source code for, this is probably the one where people are going to get this stuck the most. So yeah, feel free to make comments or questions or suggestions in the comments below, and thank you for watching. Bye.